Hi everyone, my name is Ryan Booz. I'm a developer advocate here at Timescale, and today I'd like to talk to you about continuous aggregates in TimescaleDB, what they are, the value they can bring, and just give you a general sense of exactly how they work. Now, this video is not going to go into a lot of detail. It's not a hands-on tutorial exactly on using continuous aggregates. I will link to other videos and some documentation below that can help you with that. But what I want to help you understand is really what continuous aggregates are and how they can really bring some value into your application. So with this video, we're going to cover really four quick things. The first is exactly what continuous aggregates are, give you a mental model for how they work and the value they're going to bring to your application. And then we're going to talk about exactly what that value is, how you can think about adding this feature into the work that you're currently doing. Then I want to give you a demo of creating a continuous aggregate. And really my intent of creating that continuous aggregate is to show you what's actually happening under the covers. To my knowledge, this is the first time we actually will show this in video, and mostly because I want you to understand the feature and how it's working and the value that we're going to be able to bring to you in the future. We designed it in a specific way so that we can continue to add functionality and features to it. And we'll talk about that briefly at the end. So let's talk about continuous aggregates, what they are. Now, in any time series application, we can get really easily overwhelmed by all of this data under the covers. So these gray dots represent your raw time series data. And rarely is your application looking at every individual data point. Now, depending on the kind of application you have, you may look at that individual data point once. When it comes in, you may need to check, has this stock price dropped or risen above a certain value? Because that will trigger something to happen. Is the monitoring on this device, has some value reached a high enough point that I need to take action? But once that point has passed, almost all of your other work over that time series data is about trends. It's about averages and mins and max, things of that nature, because you want to see just the trend of something over time. Again, stock data, we want to know, is the stock price going up or is it going down? What's the opening and closing value per hour? Maybe you want to do a candlestick chart if you trade stocks. Maybe you're looking at machine health and you need to know, on average over the last week or month, is the machine running worse or is it running better than it has been? And that's what time bucketing functions allow us to do. We say, give me buckets of time, an hour of time in this example. And within that hour, every hour of time, give me the max and the average and so forth. And so that's really valuable. It allows us to draw charts. It allows us to do reporting. We can get these rolled up values, but they can be really expensive to compute. If this raw data, if these gray dots represent hundreds of millions of rows, that can take a lot of work and a lot of effort. And if you're maybe developing a dashboard on top of it, it's just going to get slower and slower over time. And particularly with things, again, I'll say something like stock data. Once the stock price has happened, it's never going to change. Computing that hourly value is never going to produce a different value. And so to query that raw data over and over again is just wasted effort. And so with TimescaleDB, we allow you to take that query and save it to disk. Now, it's very similar to a Postgres Materialized View, and that's something a lot of people compare it to, and I want to show you how they're similar and how they're different. So we allow you to take that time bucket aggregated query and save it to disk. And then the value of that is you now have that raw data materialized, that aggregated data, and it speeds up your long-range queries significantly. Now you don't have to look at the raw data every time. And one of the other great benefits we provide is that we can update the values of this on a schedule. And I'll show you that through this slide deck. So taking that exact same query, we can now create a materialized view with our little hook, right? So we now say, hey, this is actually it's a TimescaleDB continuous aggregate. And we create effectively a new table for you with that data already rolled up. And now I can query that table rather than all the raw data. So let's look at how these are similar and different from materialized views. So the first thing to recognize is that continuous aggregates store partials of the computed data, and you'll see a little bit later what that means. Whereas materialized views actually store the raw computed value. So if you say min, max, average, whatever, The value that that query produces is what's actually stored to disk as a new table form. Continuous aggregates only refresh parts of the aggregate that have been modified. This is a really powerful feature because materialized views is a once and done feature. So every time you refresh a materialized view, it reruns the entire view query, creates a new table, drops the old one, and replaces it with a new one. Now you do get updated data, but it's very resource intensive. It can be, depending on how much data you have. And it doesn't allow you to retain any history, one of the benefits of continuous aggregates. Continuous aggregates also inherit the hypertable partitioning under the covers. So as your data grows, as the continuous aggregates gets bigger and bigger, we create new partitions for your data that allows us to do things like a query planning optimization to only query portions of the data that satisfy your query. And then finally, one of the other things is we allow you to do data retention. So I mentioned that earlier. Because we can refresh individual portions of that data, and because it's now hypertable-like in the partitioning, we can actually drop portions of the continuous aggregate while keeping newer portions of it so that you have a longer range history of time. Again, with materialized views, there is no way to retain history. Two more things to talk about. One is that, again, we can automate this refresh. So you can say, hey, refresh the continuous aggregate, whatever has changed, run a job every hour and update that view just so I'm sure I have the new data every hour. With materialized views, there's no way to actually schedule that currently in Postgres 14 or below. So you have to do something. You have to create triggers, or you have to create external jobs that will help this materialized view actually get refreshed. And again, remember, you're always refreshing the entire view. One thing to mention, though, is that continuous aggregates currently, again, are focused on time series data and your hypertables specifically. And so continuous aggregates are only intended to aggregate raw hypertable data. So you can only reference one hypertable, and you currently can't do any joins within the query of that view. We'll talk about why that is and how you can use that data later in other joins. With materialized views, you can really create a materialized view of almost any query that you can come up with. And so there are some limitations, but you can do something a little bit more complex there, maybe to the detriment of the performance of other portions of your app, though. So you really have to understand the value. So how can continuous aggregates help you in your application? Well, hopefully, if you've started to understand the similarity even to materialized views, you see that this is almost all about saving resources, right? Whether it's computational resources, whether it's your time as a resource, continuous aggregates help save that resource. Let's give you one quick example, just in physical data amount. Let's say you take 1,000 devices and you're storing one reading per minute, maybe one row per minute. Now, if you had many readings in one row, you would have approximately 60,000 rows per hour. If you needed to do an hourly bucket, you would have to query 60,000 rows. Now, if that value is not going to change and you create a continuous aggregate, you could take 1,000 devices. You now have that one aggregated value for every device, and you end up with 1,000 rows. That is a 60x savings that you can now query every time, and you're querying that much less data every single time. It's faster, it's more efficient, and it's just simply doing a lot less work in your database that you can dedicate to something else. So now, again, we've taken all these gray dots, we've actually done the aggregate and saved them into those data points that we can query over time. Now, the other really powerful benefit then of continuous aggregates, as I said, is that we have the ability to update individual slices of time. So even if I have that continuous aggregates, if new data points come in represented by these green dots, we can specifically go to those little portions of time and update that slice of your continuous aggregate. Again, something that you cannot do with materialized views. And you do this with what we call a continuous aggregate policy. So let's say we have a bucket width of 1 hour. That's what I've been showing you through this video. So we're going to take 1 hour time buckets. And for me and my application, I care most about the last 12 hours of data. So I want to make sure the last 12 hours are always up to date. And so I'm going to run this schedule every hour. And I'm going to look at the last 12 hours and see if any green dots have changed. And so in this example, that is represented by this blue window. So every hour, continuous aggregates are going to update, and it's going to look back 12 hours based on the policy I just showed you. And so anything that falls in this blue area, like these 2 green dots down here, we would say, hey, something has changed underneath that continuous aggregate in those slices. And we can just go update that hour of time. We don't have to update the entire continuous aggregate. This makes them really efficient to maintain. Now you might say, well, what about those green dots outside of that window? Well, that's again where we give you tooling to decide how you want to update that. You can now create a different policy that maybe goes back further in time if you want to make sure that your history is also up to date. But you don't have to do the entire time range, potentially days or weeks or months, just to get the newest data up to date. So again, once you create the continuous aggregate, it is like a Postgres table. It supports full SQL, so you can join it to other tables. You can get more value out of the data that you've computed. You get those query planner benefits because we have chunked hypertable-like storage. And again, it just saves you computation. You could literally be saving hundreds of millions of rows of data of querying time that you just don't have to do anymore. And that brings a lot of value. So let's go ahead and look at a demo of continuous aggregates. It's going to be brief, but it's mostly so I can show you what's happening under the covers. All right, so this data set is actually new to our group. We're starting to look at creating a stock application, trading, tracking highs and lows and so forth. So it's not very big. It only has 6 million rows in it. Typically, I would demonstrate something like this on maybe 100 million rows or something like that. But stocks are pretty easy to understand. Most people, even if you've never traded a stock, understand the basics of highs and lows. A price is going up, a price is going down. And often throughout the day, you need to track buckets of time. What has happened in 15-minute intervals? We call that something like a candlestick chart. Show me the last day in 15-minute intervals so I can see the highs and lows within that interval. Is the stock going up or down over time? What's the trend of that stock and so forth? So if I were to run this for every stock in this database, we have, I think, 100 stocks. We have a few months of minute data for all these stocks. So this gives me 1 hour buckets for all of the data I have for all of the stocks that I have. That took about 8 seconds, maybe 6.5, 7 seconds. Now, I'm not going to obviously always query all of the stocks. I'll probably filter it to something. But if I still have to update and scan through all of that data, it's a lot of work. Instead, I can take that query and I can create a continuous aggregate out of it. So I'm going to do that. And as this is running, it's actually creating the aggregate under the covers. It's actually storing it to disk, and I get that continuous aggregate created. And so now I want to show you the benefits. So let's say I take that raw query and I go to the raw hypertable in all the slides I've shown you, those gray dots underneath. And I want to look at Google for the last week and get these aggregates, the min, the max, and so forth. Now, in Postgres, I'm going to actually show you the amount of work that's happening under the covers through explain and analyze. If you don't know what that is, you can look that up. It's a way of seeing exactly how Postgres is producing the result for you. Now, that ran very quickly. Even though I have 6 million rows of data, I limited it to the most recent week. And I ran the data, and it only took about 38 milliseconds. Now, that is not slow. That's pretty fast, right? Now, I might expect it to be faster than that, depending on the resources. But one measure of work within a database that a lot of people don't talk about is what's called pages. So how many individual units of disk page memory data did the database have to read to produce your result? So going against the raw hypertable, Postgres had to read almost 90,000 pages, and a page is about 8 kilobytes of data. And so, this is megabytes. This is probably, I'd have to do the math, but this is probably a couple hundred megabytes of data that I had to scan through just to get the results for this query. If I take the exact same filters against my continuous aggregate, you'll see that I do a significantly less work. Now, I only had to look at 38 pages of data. 90,000 to 38 just to get the exact same result. Not only that, we are now sub-millisecond. We are now half a millisecond to get the result. All right? So this is a huge benefit for you and your application. And just to show you that we get the result, I should show you that. So there's our actual result, bucketed over time for the last week. Now, one thing that a lot of people don't know is what's actually happening under the covers, and that's what I want to show you. So I'm going to query one of our informational views called continuous aggregates, and I'm looking for this specific continuous aggregate, and I can see that it is actually stored in a materialized hypertable named materialized hypertable 40. And so I can directly query that hypertable just to show you what's actually stored. Now, you would never, ever query this table directly for anything in your application because it doesn't have a lot of meaning to you. What we are storing is what we call partials. What's actually happening is an encoded set of data that helps us come up with the result needed for your query. And we do this for a couple of reasons. What I'm not showing you here is actually elsewhere. There's actually a chunk ID. And so we are able to individually go to each little chunk of original data and find what is needed to keep this continuous aggregate up to date. Now, a lot of people might say, why did you do that? Why didn't you just store the value, the raw decimal values there, the double precision? One of the biggest reasons is this. We designed this looking and thinking into the future. Currently, continuous aggregates are not available in a distributed timescale database. You can't have a distributed continuous aggregate. But because we created this as partials, it gives us the option and the opportunity that eventually we'll be able to give you a distributed hypertable. And because we are getting the individual components to come up with the value like average, you won't end up with an average of averages. We can say, give me all of the rows, give me the total of all the counts, and still get you a precise average. And so that's one of the main reasons we did this. It also is to give us more flexibility on keeping the continuous aggregate up to date with a really efficient way of doing that. So that's actually what's under the covers. I just wanted you to see that. And this is a main big difference between continuous aggregates and materialized views. Now, I'd also like to show you how to create a continuous aggregate policy. This will keep that aggregate actually up to date over time, as I showed you in the slides. So in this case, as an example, I might take this hourly stock data, and I would say, hey, every hour, the schedule interval is every hour, rerun, look at the continuous aggregate and see if anything has changed over the last 5 days. Maybe we've added a new ticker that we want to track. Maybe we realized our service wasn't working and it imported data incorrectly for a portion of the last couple of days. And so if we modified or we added any new data under the covers in that hypertable over the last 5 days, then this continuous aggregate would now get updated and reflect the newest values. So simply creating this policy, and it gets created, and now I don't even have to think about it. The policy is kept up to date. So hopefully that helped you understand really briefly how continuous aggregates work, and even being able to see what's stored under the cover hopefully gives you a new view of how they work and really some of the features that we're hoping to bring into TimescaleDB with continuous aggregates. So depending on when you're watching this, this development future work that we're planning to do is as of TimescaleDB 2.3. I'm sure that even a few months from now, some of these things will have been accomplished. And so if we haven't had a chance to update the video, keep that in mind. A couple things to recognize. So as we did mention earlier, continuous aggregates only support one hypertable with no joining in the query that you actually aggregate. Now, I don't know that this is a specific future development, but probably giving you more options of how you can create that data to more effectively line up with maybe things like data warehousing, things of that nature. Currently, you cannot do order bys, distinct, or filters within a time bucket, within a continuous aggregate. We are accomplishing some of these with some new functionality that we're providing through a separate extension with analytical functions and so forth. You're going to hear more about that, and hopefully we'll have links in the description as that becomes available. Window functions are not currently supported. Again, something that hopefully we'll be able to support eventually. As I said earlier, distributed hypertables are not supported. So that means that if you have a distributed hypertable, a continuous aggregate currently cannot query that as a source. It's only a regular hypertable on an access node. So if you're using multi-node timescale, continuous aggregates are not currently supported for you on your distributed hypertables, something we're actively working on. That also means that currently there's no distributed continuous aggregate. So I can't take a continuous aggregate and distribute that data over multiple data nodes in a multi-node setup. Because of those partials, because of how we store the data, that opportunity does exist and something we are working on. One of the last two things to talk about is compression is not yet supported. So if you have looked at hypertables, we have a number of videos on this. We support best-in-class compression. So you can take data and honestly compress it sometimes 95% or more. Continuous aggregates are not able to be compressed yet, but again, it is something we're actually working on right now, and I would expect if you're watching this video even 2 or 3 months after I've recorded it, you probably are able to do compression on continuous aggregates now. And finally, continuous aggregates cannot be created from a continuous aggregate. We do get this question quite often. I've created a 1-hour time bucket. So just like that stock example I just showed you, can I now create daily time buckets off of that continuous aggregate so I don't have to scan my hypertable again? Currently you can't, but again, because of how we store the data, because of those partials, we have the opportunity to provide that functionality. And it's something that we are working on and thinking about, very, very much, because we want to provide that value. So hopefully this video has helped you get a little bit better understanding of what continuous aggregates are, how they work in TimescaleDB, and really the value they can bring to really make your application just more performant, respond better, and just work overall more effectively for your reporting and your charting and so forth. Come visit us at docs@timescale.com. There's a lot of information about continuous aggregates. This is one of those features that will really transform how you work with time series data. You can come visit us in Slack. You'll find me and other engineers from Timescale. Over 6,000 community members are active in that Slack channel now, and it's just fun to watch. Please subscribe to this YouTube channel. We are updating here often. We are hiring more and more developer advocates, and you're going to see new videos and new content weekly, if not multiple times a week, starting over the summer here. So we're really excited about that. Hopefully this has been helpful, and I'm just excited to see you and your application work better and more effectively because you have a tool like continuous aggregates. Take care. Thanks for watching.